Welcome to my channel, Lion Coding in the Attic. We're looking at lesson 3, creating a search index with static field mapping. This is part of unit 10 on searches. And all of this is part of our MongoDB challenge, trying to complete this course, the introduction to MongoDB, within 30 days. So I've just watched a video on creating a search index with static field mapping, as opposed to the last one, which was on dynamic field mapping. With static field mapping, what we do is that we select ourselves the relevant fields that we think the user will query, and that will actually help us make our query faster. So let's have a look at our lab. Okay, so we're creating here a static search, sorry, an Atlas search index with static mapping. Okay, we'll use Atlas CLI, specifically the command Atlas clusters search indexes create. Okay, that's the one we've used before. And we'll create an Atlas search index static mapping for the specified set of fields from our data. Okay, we have a data set that contains records from an office supply company. The records contain information about orders, products, and customers. Imagine we're working on an application with a dashboard for administrators keeping track of sales at our office supply company. We want to add search functionality so that administrators can easily find sales matching their criteria. Okay, so exactly the same that before. And we need to create a search index for the sales collection. So we'll open the search index.json file, which is here. Okay. And I just need to edit the JSON file to the value string to reflect the sample below. So that makes sense because what we're looking for is text here. Okay. And this will be automatically saved, and we'll need to run. So we'll copy this first because I'd like to read it properly. So this is the command Atlas clusters search. So search is on the Atlas clusters. We're creating an index with the name. The cluster name is my Atlas cluster EDU with the elements in the search index.json file. Oops. Can't be found. Can't be found. How come? Okay, so we can see that now the index has been created, and we can check whether it's actually there. And we can see that we have the name of our static indexing here that we had. That was the name of our search index. Okay. Okay. Okay, so now we'll use Mongosh and the aggregation framework, specifically the search stage, to use our newly created Atlas search index. Okay. So copy and paste the following command to use Mongosh to connect to your Atlas cluster. For simplicity, we have included your connection string in the command by using the bash variable myAtlas connection string. Well, that's handy, thank you very much. And appended the correct database for this lab. Okay, let's have a look at that. So Mongosh, myAtlas DB user, my connection string, etc. Okay, seems to be connected. Next, create an aggregation pipeline for which will contain 2 stages. Forgot the method for aggregation. Yeah, did forget. Let's have a look at the hints I forgot. Remember that an aggregation pattern must start with DB, aggregate. I did forget what aggregation means, to be honest. Okay. So let's have a look at aggregation pattern. This is one of the more stages of produced documents. Oh yeah, I remember. Okay. We did spend a whole module on this. This is where the process that we're creating to perform certain things on our documents. Okay. So like search, stage, etc. Okay. Now that does ring a bell. Okay. So, and what do we need to do? So there will be two stages. Okay. So what I'll do, I'll use VS Code. I'll use VS Code because it will be easier to look through, do stuff like that. Okay. I do have an aggregation thing that we've done before. Okay. Let's start from scratch. So DB dot, what's the name of our collection? Sales collection. Okay. And we'll run an aggregate method. There, here. The first part was a search. Search. Actually, I'm not sure about these brackets here, the square brackets. The way it's supposed to be. Yeah, you've got here and you've got the, no, that's insert menu, aggregate, stage one, stage two. We do have the square brackets and match, group, etc. Okay, so what do I need to do? Aggregation pipeline goes in two stages. So the search stage used the index simple supply cell static with a query value of London. I do this. The query value of London and a path wildcard of asterisk. Uh, yes, I need to look at. So what does it say here? The format of the search stage requires an index field and a text subdocument. Oh God, I have no idea how to do this. Let's perhaps look at the structure of search. Okay, let's try and apply this. So we've got our search stage. And they said that there would be an index field and a text field, as far as I remember. Okay, so for the index field, we should use our newly created index. No. Got the name of our index. True value will be London, and the path will be asterisk. Then we need to add a set stage. That adds a new field score to the document that represents the Atlas search score. Okay. So the field will be named score with this expression here. Okay. So let's try and run this. Text must be a document. Okay, well, I'll just copy this into ChatGPT because I think I'm mixing up different things in my head. It's not quite clear. Um, okay, so what does it say? That text is not used in the right way, should be text as the operator inside search. And the path should be a string, not asterisk. Okay. All right. Okay. So this part's right, at least. And here I needed to use the query and path as a subfield. Okay. Okay. So let's copy this code and see whether this actually works. Okay, how can I see whether it actually worked? So there was no error on the CLI at least. So I've done this, added score. Okay, it seems to be okay. Let's have a look at the code. Aggregate, search index with the name of the index, the text with the crew London and the path. Okay, no. See, I should have used a wildcard. Okay, so instead of field 1, 2, and 3. Okay, so I've got results, but I don't really see the was I supposed to see the score somewhere? Oh no, because it wasn't in there. Okay, sorry. So we've created this. Ooh, this is going to be a problem, I guess, if I try and run this now. Oh yeah. Oh, good. So this, okay, because we've got in this code here the set method, so the set stage. So we've created the score here and it appears here. Okay, that was a difficult one for me. I don't know whether you guys found this easy, but for me it was really, really difficult. I think because I forgot how to use this search stage here with the index, the text, to query the path. It was completely forgotten this. Maybe I'm just stupid, but I just forgot. Okay, let's have a look at the quiz now. If the search index is statically mapped and the only field mapping is for the store location field, and you search for one of the items sold by the other supply company, notepads, how many results will come up? So statically mapped, one field, store location, and we looked for items. Uh, I guess none, because if we've mapped the store location, it won't come up with the item field, I guess. Yes. Yeah, because we haven't indexed it, so it can't be found. Makes sense. Okay. The following code is a snippet from a search index. What type of field mapping does the search index use? Dynamic. Switching here. Dynamic true. Oh no. Oh, hang on. Oh, I got mixed up. Okay. Yeah, I got chapped because I looked at this dynamic, but we should have looked at this dynamic here, which is a dynamic mappings, and this is dynamic in the fields. Okay, and what they say is that because it's set to false, the dynamic one here, that means that all fields are not weighted equally. Okay, and we have specific settings for the common name here. Okay, All right, guys, I think that's the end of today's lesson. Thank you for following along. It was quite a hard one for me. If you'd like to see more videos like this, please hit the subscribe button and the like button, and I'll see you in the next one. See you soon.